Okay, so we are going to start the concept of and to understand the concept of stability, right? So मैं क्लास में बात करता हूँ तो stability में हमें what we have to understand in the stability, you can see here there are three types of picture is given. First one you can see it is the most stable system. Okay, मैं अभी क्लास में हूँ है ना, मैं क्लास में करता हूँ कॉल. Okay, and second one you can say the neutral system, and third one is the highly unstable system, right? So how this system it decided the stable or neutral or the unstable based on this concept. So you can see here when a process is disturbed, okay, or perturbed from initial steady state, okay. So by implementing some input force, when you supply some input force, then we have to check either this will suppose that we have some applying some input force, then what happened to this system, okay. So it will be remain stable or with the neutral or the unstable, we will decide with the help of this response. So first proceed to a steady state and remain there. Three conditions may be there. First, if we disturb the system, then it will remain again in the steady state and remain same. Second one, failed to attain the steady state condition because its output grows indefinitely, right? And third, failed to attain the steady state condition, but it has a constant, oscillate continuously with a constant amplitude. It means the system may attain like this, the system may attain like this, the system may attain like this with a constant amplitude, right? So which type of system may be a stable or unstable? You can see here, this is the growing indefinitely, but it is settled down after some time, right? It is the set point, our set point is this one, so it goes to the settle down to the, it is not blown up, it is not, you can say the blown up, okay. However, this is the blow up, and here it has a constant oscillate indefinitely but with a constant amplitude. So which type of system is called to be stable? So this system is known as a stable. However, this is unstable, and this system said to be, anyone can tell, such type of system is known as
Oscillatory.
marginally stable. What do you
Marginal
understand?
stable.
What do you understand by this stability? We will discuss here. Okay, so stable, neutral, and stable, or you can say the marginally stable, right? Marginally stable. So the definition is very clear. It now seems perfectly logical to consider the process that ultimately settles down after having disturbed. Ultimately settle down after having disturbed as being a stable. It is called the stable, okay. And that, and the one that fails to settle down is called the unstable, okay. So which are going to settle down, that the system is said to be stable, or which not going to settle down, that is unstable. It is a clear definition of the stable, but it is not a definition, it is not a mathematical definition for the stability. So one another definition is has been defined for the sake of the mathematics. If in response to a bounded input, your input should be the bounded and output should be also the bounded input and bounded output. It is the main key of the stability. Okay, the main key is the concept of the stability. So your input should be the bounded. If in response to the bounded input, when you provided the input bounded input, then your dynamic trajectory of the system remains bounded, okay. Output also remains bounded as t tends to infinite, then your system is said to be stable, okay. If you provide some input, bounded input, if your output remains bounded as t tends to infinity, then you can say that the system is stable, otherwise system is unstable. So for the system, for the study of the linear system in the process control, or in the control theory, you can say the concept of BIBO stability we can use, okay. So the question, there are different types of the question we arises here. When the linear system is stable, when the non-linear system is said to be stable, can a system that is stable by itself? We will try to search the answer of this question, okay. So as you have seen here, the system is said to be stable or unstable Okay, system is said to be stable or unstable. You can see from this picture. Let's say we have there are different types of the pole. Okay, I am defining here. Okay, so you can see if if the pole is lying, if all the pole is lying in the left hand side, then you can say the system is stable, or you can say the pole have the negative real parts. Why it is called the negative real parts only, we will discuss. Okay, because it may be the, the pole may be the imaginary complex pole. Pole may be the complex, right? And if the real part of that complex pole lies in the left hand side, left hand of the S plane or the complex plane, you can say the system is stable. Okay, otherwise system is unstable. Why I am saying such type of things? So let's say we have the left hand post and it is a right hand post. We already have discussed, if the poles is lying in the left hand plane, then you can say the system is stable, or if the pole is lying in the right hand side, then the system is unstable. Okay, and what happened when if the pole is lying on the marginally imaginary axis, then system is marginally stable. It is not totally true. Let us consider first, it is not, it is this statement, it is not completely true and for any cases. Okay, so what do you mean by, first of all, bounded input and bounded output? You can see here, it is the bounded input. If the output is bounded, it is the unbounded case. However, this is the bounded case, right? So this is the bounded. You suppose that you have provided the ut ut means a step signal, right? You have provided the step signal, then you can see the step signal is a bounded signal, right? This is the bounded signal. Okay, and when you got the output like this, let us consider this is also the bounded. Okay, after at the infinite time, at t tends to infinite, you can predict the final value. What is the value? Okay, therefore I'm saying this is the bounded output, right? So thus for the any bounded input and the output either remains constant or decrease with the time, then you can say the system is stable. Remember, it is very, very important. Either the output should be the remain constant or decrease with the time. Decrease with the time or maybe the constant. In these two cases, the system is called a stable. However, this is the margin stable and this is the stable. How? See, it is the unbounded signal, right? It is the unbounded signal. Therefore, I am saying unstable. Unstable. Okay. Let us consider. देखो यहाँ पर ध्यान से. Let us consider we have the pole S is equals to -3. S is equals to -3. So what is the response? What is the Laplace inverse of this function? Anyone can tell me?
e to the power minus
e
3t.
to the power minus
e to the power
3t
minus 3t means this like this. Yes or no? Yes
yes
or
sir.
no? So it means t tends to infinite. What is the nature of this shape? What is the nature of the system?
Zero.
It tending
0.
towards it tending towards zero. Yes or no? It tending towards zero or decreasing. And what I'm saying, it is decreasing. However, in this case, s is equals to 3. Then the Laplace inverse transform of this function e to the power 3t. So it is blows up, and therefore it is unstable. It is stable. It is unstable, right? Therefore, we are talking about the pole location. If the pole is lying in this left hand side, then ultimately at the t tends to infinite, it will decrease because exponentially decreasing. However, if the pole is lying in the right hand side, then your pole, your graph, you can say the response will blown up, or you can say the unbounded, and therefore it is unstable, right? Okay, now this is the case. Okay, you can see here this is the stable. Okay, based on the different types of the pole location, we are going to discuss the stability and the unstability. The stability and the unstability. Now I have the different types of the cases I want to discuss here. That is the, wait a minute. Yes, yes. Let us consider we have one. आपको कमेंट करना है, प्लीज कमेंट ऑन द स्टेबिलिटी ऑफ द सिस्टम. लेट्स से इफ the location of the pole is like this, then what is your comment? It is the stable or unstable?
Stable.
Stable. Why? This is absolutely stable. Absolutely stable, right? Why? Because if the graph you see e to the power minus 80. Okay. Let's say if there are double pole lying at the same location, it A. So what is this? This is the FSH equals to, you can say, S plus A whole square, if I'm not wrong. Yes or no? So if it is S to the power A square, what is the Laplace inverse of this function? T e to the power minus 80. So T to the power minus 80 means T means it is going up, and then due to the e to the power minus 80 it will be decreases. Okay, ultimately it will decreases, right? So at T tends to infinity, again the system is going to settle down towards zero, and therefore we can say that the system is absolutely stable. Okay, now come to the next, and that, let's say we have the pole at minus a, sh equals to minus a plus minus jb, minus a. Okay, this is the, sorry, this is the, oh my god. Okay, no problem. Wait, sorry. Hmm. Okay, so let's say we have one pole sh equals to minus a plus minus jb. Then you can say there are two types, there are two poles lying at the location of this is, this is the minus of jb and this is the plus of jb. This is the complex imaginary plane and this one is the real plane. So what is your comment of this first such type of function? Fs equals to, you can see, 1 upon s plus a whole square plus b square. Am I right? Yes or no?
Yes, sir.
Yes or no? Yes, sir. Because s is s plus a minus of jb and s plus a minus of, sorry, plus of jb. This will be the function. So 1 upon s plus a minus of jb and s plus a plus of jb, it will become, 1 upon s plus a whole square plus b square. Am I right? So this is the case. Yes. And the Laplace inverse of, what is the Laplace inverse of this function? If you multiply it by b and divided b, then it will becomes the, please tell me, a to the power minus 80 sine of bt. Am I right?
Yes, sir.
Yes, sir. Yes or no? Yes, sir. So it is sine bt, sine function will be like this. Yes or no? Absolutely. And the e to the power minus 80, e to the power minus 80 is like this. ठीक है? E to the power minus 80 function is like this. However, the sinusoidal function is like this. So the ultimately it will decreases and, damped type of system, and ultimately the system will stable. So you can say that it is the absolutely a stable system, right? Now come to the next, and we were going to discuss another case. Let's say we have the pole. Now we have discussed the one pole in the right hand side, two pole in the right hand side, and double pole in the right hand side, and complex pole in the right hand side. Sorry, all the in the left hand side. Now I am going to shift our pole at the origin. So what is your comment? This is the 1 upon S, nothing else. So FT becomes UT, yes or no? FT becomes UT. And what is the graph of this such type of function? This is, yes or no? So this is at t tends to infinite, this function is not going to towards the zero. It is not approaching to zero, or it is not decaying type of the system. Okay, and you can say that this is the constant value. Ut has one, let's say the amplitude of this function is 1, so it have a constant value, and therefore you can say that this such type of system is which type of stable? Absolutely stable.
Marginally stable.
Yes, marginally stable. Very good. So this is the marginally stable system. Now please tell me, let's say we have another type of case. Let's say we have the pole at j plus j and minus j at the imaginary axis. There are two types of the two poles. Okay, now please comment. What will we write? 1 upon s square plus a square. If right, s is equals to plus minus j. So s plus j and s minus j. Okay, and it will be the s square plus a square. Am I right?
Yes, sir.
So if you draw the curve, then we will get the sine 80. Yes or no?
Yes,
Yes,
And
sir.
again, it is the constant value. Am I right?
yes,
So please
Yes,
tell
sir.
me, what is the stability criteria? What will be the stability comment? It is the marginally stable or the
Marginally.
absolutely stable or the non-stable?
non-stable.
Alright? It is has a constant amplitude,
Marginally
na?
stable.
It has a
Marginally
constant
stable.
amplitude.
Marginally stable.
Oscillate,
Marginally.
but with have always remains a constant amplitude. It is not going to the blown up or not going to settle down. Okay, at a constant amplitude, it is rotate, it is oscillating, and therefore it is called the marginally stable. Remember, marginally stable, right? Now, another case I am taking. Let's say we have the double pole at the origin. Double pole at the origin. Then, what will be the pole location? Please tell me. S is equals to Fs is equals to what? 1 upon
1 by s
s square.
square.
Yes, 1 upon s square. What is the Laplace inverse of this function?
T,
Ft is equals to t. And what is the
T.
nature of t?
linear.
This. So, linear
RAM.
to hai, but it is bounded or unbounded?
Unbounded.
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 So, since the signal is unbounded, then you can say the system is stable or unstable. सर अभी क्लास में
Absolutely unstable.
Absolutely unstable. हाँ बताइए ना.
Unstable.
हाँ क्लास में. हाँ अभी. हाँ ठीक ठीक. Unstable. ठीक है, unstable system. Okay. Now consider the another case. Another case. Let's say we have the double pole at the different type at the imaginary axis. Then what will be your comment? It will be s square plus a square to the square. Yes or no? Same case,
Yes, sir.
but having the double. But having the double pole. तो एस स्क्वायर प्लस ए स्क्वायर होगा, क्योंकि ये डबल है तो यहाँ पे स्क्वायर हो जाएगा. यस और नो? ओके, सो what will your comment? It is the t sin t. यस और नो? अगर ए से मल्टीप्लाई कर दे 1 अपॉन ए से डिवाइड कर दे, तो इट इज नेचर लाइक t sin t टाइप. यस और नो? तो t sin t का नेचर क्या होगा? t sin t means this is a t,
Increasing.
and sin t means increasing. Okay, so this function is stable or not stable? Please tell me.
Unstable.
Unstable.
Why?
Unstable.
Why?
Unbounded.
Because unbounded.
Unbounded response.
So this is the unstable. Okay. Now I think you understand the case. How can you identify the stability and unstability of the system? Now you can comment. So let's say we have the double pole at this location. तो एफ एस इक्वल्स टू क्या लिखेंगे? 1 अपॉन एस माइनस ए होल स्क्वायर. यस और नो? एस इक्वल्स टू ए. So what will be the function? Please, ft is equals to
T,
t to the power 80. Or t to the power 80 means the curve is like this. Yes or no? Curve is like this. So system is unstable. Why? Because this is again unbounded. Okay, let's say we have a single pole 1 upon s plus a, sorry 1 s minus a, again e to the power at. It is the unstable because this is the unbounded. Is it clear? Now one interesting case now I want to take, and this case is like, let's say we have the pole location at this place and this place. Okay, we have the imaginary pole location. Let's say this is the a and this is the plus jb, this is the minus jb. What is fs? fs is equals to 1 upon s minus a whole square plus b square. We have already seen, यहाँ पर था तो देखा था हमने, yes or no?
Yes, sir.
Yes, sir.
So what will be the ft? ft is equals to
E to power
e to the
80
power 80 sine of bt type
sine
function आ रहे हैं,
and BT.
है ना? तो इसका क्या हो जाएगा आपका? It will be the blows up because e to the power minus 80 is like this and sine bt is like this, and again the system is stable or unstable.
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 Okay, so this is the case you can identify from such type of system. Okay, now I'm coming to the next, that is your stability and stability part. Okay, तो ये हो गया हमारा. So ultimately you have to check what? You have to check the bounded and unbounded, and also you have to check that as what is the characteristic, what is the behavior of the response at t tends to infinity. Yes or no? Yes or no? At
Yes,
t
sir.
tends to infinity, you have to check the response, either it is a constant or settle down yt tends to 0 और yt is unbounded. यही आपको तीन चीज चेक करना है. तो इस तीन based on these three you have to comment the system is stable or unstable. So it is very true to say that the system, if the for the stability, the system for the input bounded, but for bounded input the output should be the bounded. Okay, so now I am going to take the state equation, and for the state equation we have to find you have to comment on the stability. Okay, so as you know that the system is stable for the state space if and only if all its eigenvalue means the characteristic, the roots of the characteristic equation, again pole location, have negative real parts, so that they lie in the left half of the complex plane and system will be stable. Okay, so this is one of the example. You can see that ys is equals to 5 upon s square plus s minus 6 is given us. Okay, it is transformed into the uh, state space equation. Okay, you know how to convert into the state space, we have already discussed. Okay, so I'm not going to the detail of this. So dx1 by dt, dx2 by dt, and y is equals to x1 we have taken. Okay, a matrix based on this equation, a and b matrix, c matrix is written. Okay, and you can find out the lambda, we can find out the lambda on from the a matrix. Okay, can see that the lambda is here minus 3 and
Minus 10
plus
to
2, and the one of the pole location is minus 3, however the second location is 2. So system is stable or unstable?
Unstable.
unstable.
Why?
Unstable.
Because one of the pole is lying in the right hand of the s plane, and therefore system is unstable, right? So a stability analysis of the closure of system boils down to investigate the roots of the characteristic equation, right? The characteristic equation is a polynomial in which in S, whose order is of course to determine the order of the contributing transfer function. It should not be too difficult to see from the above example that for lower order polynomial characteristic equation, roots are easy to find, है ना, or stability you can carry out. But however, for the higher order polynomial, there is no, it is very easy to find out the roots of that system. It is very tedious task to find out. So therefore, in order to comment the stability of the higher order system, you have to perform different types of the test, that is the Routh, Hurwitz, and based on the polynomial, right? So such type of stability criteria is going to going to test. It is a test for to investigate the such type of stability, right? So I'm not going to detail of these such type of the things because we will discuss it in the process dynamics and control. Okay, and now I am coming to the next part, and that is your stability. Okay, yes. So we have discussed these things. ये हमने बता दिया. Okay, marginally stable, relative stable we have. So this is the uh, Routh stability criteria for the higher order of the polynomials. Okay, I'm not going to the detail of this because and this is not desired for our state space. Okay, root locus and these things are there. Okay, so I hope this is the enough discussion for the system. So now I'm going to just wrap up about the stability in 2 to 3 minutes. Okay, so if you want to write what is the stability, okay, so you can say that a continuous LTI system is exponentially stable when, please tell me, if and only if, please tell me, if and only if,
Eigenvalues have negative real part.
yes, the system has eigenvalue, and that eigenvalue, that is the poles of the input to output system, right, with strictly negative real parts. Okay, real parts. Real parts का negative real parts का मतलब क्या है? That is in the left half of half of
Yes,
the
sir.
complex plane, right? The complex plane, and the system is said to be stable. You can also say that an exponentially stable LTI system, okay, is one that will not blown up. Am I right? Blown up. If the system is blown up, then system is unstable. Okay. Blown up का क्या मतलब है? Please tell me. What is the meaning of blown up? Gives an unbounded response. Yes or no? Unbounded output. If the system is unbounded, then you can say that again the system is unstable, right? Okay. Okay.
Yes, sir.
Now, there is another term which come in the picture. First of all, I want to discuss the marginal stable. Okay. If the oscillation do not die away, or you can say the system does not return to its original output, then the system is known as you can say the have the marginally stable. Yes or no? Marginally stable. Okay. One another term that will come in the control theory, that is the asymptotically stable. Asymptotically stable. And we have to understand the meaning because we have to also cover the Lyapunov theory of stability in the nonlinear system. We will discuss in the upcoming lecture. So for that purpose, asymptotically stable system you have to understand. What to understand by the asymptotically stable? So it is defined, a system is defined to be asymptotically stable, right? if the response decays, remember, exponentially towards 0. मतलब क्या हुआ, at t tends to infinite, yt tends to be 0. Yt tends to be 0. And then you can say that as time approaches to infinity, right? So यही बात हुआ. इसका मतलब then system is said to be asymptotically stable. Yes or no? Is it clear?
Yes, sir.
Okay. Now, last, let's say we have the x dot ax. We have the function, we have the state equation x dot ax. Okay. We will also discuss what is the solution of this function. Please tell me. X2 is equals to
Phi t x naught
phi t
Phi
x naught.
and
Yes,
x
X.
naught.
very good. Phi t. What is the phi t?
SGM.
E to the power
State
E to the
transform.
power 80.
80. Yes or no? Yes.
Laplace inverse of SI minus A inverse.
Yes, yes. Laplace inverse of, yes, बिल्कुल ठीक है. So in another term, देखिए अभी मैं इसको बताया नहीं हूँ, लेकिन I will discuss how it will come. In other term, the solution, this solution is also written as, t e to the power dt t inverse. T e to the power dt t inverse. What is the t? T is the eigenvector. Remember, t is the eigenvector. D is the diagonal matrix. ठीक है, diagonal matrix. Okay. So e to the power dt is equals to, you can write e to the power lambda 1 t, e to the power lambda 2 t, up to the e to the power lambda and t 0 0. Okay, and like this. So this is the like case. Now try to understand what I want to say here. Let's say we have the lambda, the nature of the lambda is like this: a to the power a plus minus jb. A plus minus jb मतलब complex pole. Yes or no? Complex eigenvalue. If it is a complex eigenvalue, then you can write that e to the power lambda t is equals to nothing but e to the power at cos bt plus j sin t. ऐसा लिख सकते हैं क्या? a प्लस jb को क्या ऐसा लिख सकते हैं क्या? e to the power lambda t को? Please tell me. Yes or no? Yes or no?
Yes, sir.
So what it will be signifies? It is the sinusoidal function. It is the exponential function. So it will the nature of this function e to the power at will tell you either it you can say either it grows or decays. Yes or no? यही तो स्टेबिलिटी बताएगा, इसका नेचर तो बताएगा कि ये सिस्टम ग्रोज होगा कि डिके होगा. अगर कुछ इस तरीके से हो, then system will be unstable. And if it's like
Unstable.
this, the system will be stable. So what is the condition? Please tell me. If a is greater than 0, then it will provide the growing function. Yes or no?
Unstable.
Growing. And if a is less than 0, then it will decay. And it's like this. Okay. So a less than 0, what it mean? It is a negative. Yes or no? So if you can say, if the real part is negative, right, the dynamics will be stable. Yes or no? ऐसा कह सकते हैं? Yes or no?
Yes, sir.
Okay. So ultimately xt is equals to t e to the power dt t inverse is stable if and only if and only if the real part of eigenvalue is क्या? Negative. Yes or no?
Yes.
Then only you can say the system is
Stable.
stable. However, if the pole is lying in this here in this area, then it is the unstable. Okay, so this is the complex plane, imaginary and real. Okay, complex plane we will denote like this. Okay, also, so lambda is the element of, you can say, the complex plane. Okay, so this type of picture will come. So this is the first part of our discussion. I am just